Good afternoon, class. We are continuing with section 5.4, the substitution rule. Here's the FTC, more specifically, the integral of a to b f of x dx is the capital F of b minus f of a. And here's the substitution rule. F of g of x times g prime of x dx is integral of f of u du. And the answer is capital F of g of x plus a constant. So you're looking for a function and its derivative. Number one, we notice here square root of 3x plus 7 or 3x plus 7 to the power of 1/2, then the choice of u is 3x plus 7. If I differentiate, I get 3, therefore du becomes 3dx. And as you recall, the way I approach this, I see that number 3 is missing. I put number 3 and undo it with 1/3. I want to show you both ways in this example. The way they do it is that they solve for dx in most texts. So if we solve for dx, becomes du over 3. And so we are going to rewrite this in this fashion. The integral of the square root of 3x plus 7 dx is the integral of square root of u du over 3. And of course, as you know, square root of u is u to the power 1/2, and you move on from here. It's a simple case of power. However, what did I do normally? I would say, okay, I look at this one and say, okay, dx, I need 3 dx. So 3 is missing. Because 3 is a number, I can put in the number 3 and undo it with its reciprocal 1/3. We can only do this with numbers. As you can see, this is identical to this. Now, u to the power of 1/2, we have done this integration a number of times, is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. And this is 3/2. This is 2/3. And their product, u to the power of 3/2. The product is, of course, 2 over 9. So we have 2 over 9, u to the power of 3/2, and we're going to replace the u. Because we like to put it back in the same format, I hope you remember from elementary algebra, this is 2 over 9, 3x plus 7 times square root of 3x plus 7 plus a constant. That is the final answer, everybody. All right, in this page, I have a couple of questions that are similar in that they both involve ln x. So generally speaking, if ln x is involved, that is a choice of you. And so, as you know, the derivative is 1 over x, therefore du is 1 over x dx or dx over x. I want you to look at both. They mean absolutely the same thing. Now, I highly recommend you always rewrite that so it becomes clear to the reader what you have. We have ln x to the second power times 1 over x dx. And therefore, you're looking at the integral of u squared du, which is a simple case of a power rule. Which is obviously 1/3 u cubed plus c, and you are going to replace the u. You get 1/3 ln x quantity cubed plus a constant. Bear in mind, don't mix up these two. Ln x cubed is not equal to ln of x to the third. Ln of x to the power of a third means ln x times ln x times ln x. This can be simplified to 3 ln x. Please don't mix them up. Let me erase my work. Now, As far as the second one, part B, is concerned, we have exactly the same u and du. Let's rewrite it. So it's 1 over ln x times dx over x. So that means 1 over u du. By the way, again, one of them I wrote it in this format, one of them I wrote it in this format. I just want you to be familiar with different formats. They mean absolutely the same thing. And as you know, this follows the natural log. So the answer is ln of absolute value of u plus c. And you are going to replace the u with ln x. So ln of ln x, absolute value of ln x plus a constant is the final answer, everybody. So that's pretty straightforward. Again, the synopsis of the section is that if natural log is involved, normally that is the choice of u, everybody. What happens when we have sinusoidal functions? If the argument, and one of them, and the argument of sine, cosine, has an exponent, the argument is a choice of u. As you know, the derivative is 2x, which makes du 2x dx. We're going to rewrite this, and we're going to move x next to dx, so it becomes clear to the reader that everything is in order. We have number 2 is missing, and since 2 is a number, we can put the 2 and its reciprocal, 1/2. Again, you can solve for dx if you find that easier, but I believe this is the fastest way. So we have half of the integral of sine u du. The derivative of sine is positive cosine, but the integral is negative cosine. So negative 1/2 cosine u and a constant. Replace the u, and we are done. What happens when you have both sine and cosine? The one that has the exponent is a choice of u without the exponent. If both of them have exponents, then you have to use trigonometric identities to bring one of them to just an exponent 1. Because the derivative of sine is cosine, the derivative of cosine is negative sine. That's why it's the methodology. Obviously, the derivative is cosine x, which makes du cosine x dx. So we are looking at u squared times du. A simple case of a power rule, the answer is 1/3 u cubed plus a constant. We're going to replace the u, and the final answer is 1/3 sine cubed x plus a constant. Now, what about this case where we want to take the integral of cosine to the power of 20x sine x dx? Obviously, cosine has the exponent. So cosine is a choice of u. The derivative of cosine is negative sine x. Therefore, du is negative sine x dx. So again, you can solve for dx, or I'm going to say, okay, I have sine x dx. Everything is in order. I don't have a negative sign, so I'm going to put negative in, negative out. It's important to know that means -1, that means -1, and their product is +1, so it's acceptable. So we are looking at minus the integral of cosine to the power of 20th x times negative sine x dx. So we are looking at u to the power of 20 du inside the integral sign. Obviously, we keep the negative sign, and this is 1 over 21 u to the power of 21 and a constant. So we get -1 over 21 u to the power of 21 and a constant. Replace it with cosine, and we are done. Substitution for definite integral of a to b, in this case 2x parentheses x squared minus 1 quantity q dx. As you know, a definite integral results in a number. So how do we do that? There are two methods. One is to return to the original variable. So First, let's integrate this using substitution method. Obviously, we have a couple of polynomials. X squared minus 1 is more complicated. The derivative of x squared minus 1 is 2x, which makes du 2x dx. So we have that. And we're going to move the 2x next to the dx, so everybody can clearly see that we are dealing with u cubed with du, but what are the new limits? We are not going to discuss that yet. The point being, you can't use the same limits here. These limits apply to variable x. So the integral is 1/4 u to the power of 4. And again, what are the limits? We will get to that. We are going to replace the u with x squared minus 1, and we go back to the original limits. Now, 1/4, if I plug in 2, I get 4 minus 1 is 3 to the power of 4 is 81. If I put 1, I get 0. And therefore, the answer is 81/4. We are done. The second method is to keep track of the change of variable. What do we mean by that? Well, plug in the lower limit, find the new lower limit, plug in the upper limit into the u, and find the new one. So x or a, the lower limit is 1. G of x is x squared minus 1. Let's plug in, and it becomes 0. So that's the lower limit. In other words, here or here is 0 if we go with u. Let's plug in upper limit. X equals b equals 2. If I put that into x squared minus 1, I get 3, u or g of b. And so we are saying the integral of 1 to 2x, parentheses x squared minus 1 quantity cubed dx, the original one, is the same as the integral of 0 to 3 u cubed du, which is 1/4 of u to the power of 4, 0 to 3. And if you plug in 3, you get 81. 0 gives you 0. 1/4 of it gives us 81/4. We get exactly the same answer. I believe this is a tad faster, but you can go either way. Which gives rise to the following theorem. If g prime is a continuous function on the interval of a to b, and f is continuous on the range of u equals g of x, then the integral of a to b f of g of x, g prime of x dx, is the integral of g of a to g of b f of u du, which simply means keep track and come up with the new limits. That's all it means. Okay. How about the integral of 3 to 4 x squared of 25 minus x squared dx? We are going through the substitution. We are going to integrate. We're going to go back to the original limits. Also, we are going to look at the new limits. So we have, if this is 25 minus x squared to the power of 1/2. So we have two polynomials where 25 minus x squared is more complicated. Therefore, that is a choice of you. The derivative is negative 2x, which makes du negative 2x dx. Let's move things around. So square root of 25 minus x squared, I'm going to put the x next to dx. Everything is in order except negative 2. You can solve for dx, or an easy way out, put the negative 2, undo it with its reciprocal negative 1/2. So having said that, we are dealing with square root of u du, and what are the new limits? Let's discuss it shortly. So we're going to stick with just square root of u and change it to u to the power 1/2 for the sake of evaluation of the integral, which uses the power rule. Again, this has been done a number of times. This remains. This is 1/1/2 plus 1 u to the power of 1/2 plus 1. 3/2. The reciprocal is 2/3. This product is negative 1/3. Again, we are not writing the new limits. at this point. We are going back to the original variable and original limit. So we're going to replace the u with 25 minus x squared, and we're going to go from 3 to 4. You can finish the job there. Or let's figure out what the new limits are supposed to be. So if I put number 3 here and square it, I get 9. So 25 minus 9 is 16. So this is the lower limit. If I put the upper limit here, I get 16. 25 minus 16 is 9. That's the upper limit. So we're going to evaluate this expression, negative 1/3 u to the power of 3 halves, from 16 to 9. So we're going to plug in 9 first, and then minus, plug in 16, and we're going to keep the negative 1/3 out. This is elementary algebra, but it's 9 to the power of 3 halves. I mean, square root of 9 cubed, which means 3 cubed, which means 27. What about 16 to the power of 3 halves? Square root of 16 cubed, 4 cubed is 64. Their difference, negative 37 multiplied by negative 1/3, you get positive 37 thirds, and you're done. So the integral of 0 to 2x squared, parenthesis 2x cubed minus that quantity cubed dx. We want to integrate this. Obviously, 2x minus 8, 2x cubed minus 8 is a more complicated polynomial. That is the choice option. And therefore, the derivative is 6x squared makes du 6x squared dx. Move the x squared next to dx, and we notice everything is in order except number 6 is missing. Again, you can solve for dx, or the easy way out, plug in 6, and do it when it's with its reciprocal, 1/6. And now we notice it is 1/6 the integral of u cubed du. And what are the new limits? Let's find out. If I plug in 0 here, 2 times 0 is 0, I get lower limit minus 8. If I plug in 2 here, 2 cubed is 8, 2 times 8 is 16, minus 8 is 8. That's the upper limit. So 1/6, the integral of negative 8 to 8, u cubed du. Obviously, u cubed is 1/4 u to the power of 4, and the product of these two is 1/24. We keep it out. Or we can go to the original one. 1/24, parenthesis 2x cubed minus 8 quantity to the power of 4 from 0 to 2. Now, either way is fine. I'm going to evaluate this part, and I'm going to show you how easy it is. This is 8 to the power of 4 minus negative 8 to the power of 4, which is 0. Why is that? Because the exponent is even here. Minus 8 to the power of 4 is identical to 8 to the power of 4. They cancel each other. So I believe this makes it a tad easier to evaluate, but it's absolutely your choice. Zero. So you can go either way, this one or that one. And of course, 1 over 24 times 0 is 0. Let's look at an application. The rate of growth of a fish population was modeled by the equation g of t equals 30,000 e to the power minus 0.6 t over 1 plus 5 e to the power minus 4.6 t quantity squared, where t is measured in years since 2020 and g of t in kilograms per year. If the biomass was 40,000 kilograms in the year 2020, what is the predicted biomass for the year 2040, rounded to the nearest whole number? So this is the same concept we've looked at, known as the accumulated change, okay, or the net change theorem, that there are two ways to do that. We can look at the amount of increase and add the initial value, or find the general solution. So having said that, it's important to know this represents the derivative of some function. In this case, if capital G of t represents the biomass of the fish at time t, then the growth rate, capital G prime, is lowercase g of t as given. So what is this? The initial value, capital G of 0, because this is the beginning, and you take that to be the beginning, and whatever this one is, the difference, of course, is 20 years, okay? And so the accumulated change theorem says, based on the accumulated change, the amount of increase over the course of 20 years, 2040 minus 2020, over the course of 20 years, is the integral of 0 to 20 g of t dt. So plug in, replace g of t, and let's integrate that. Because it's a fractional format, the first step is to put it in lowest term. It is in lowest term. There's nothing else you can do. Therefore, the denominator without the exponent is a choice option. So notice, if I want to differentiate this, in other words, du dt, 1 goes to 0, 5 e to the power minus 0.60 is itself. Why is it itself? Because an exponential. And by the rules of exponential, times negative 0.6. The product of these two will give us negative 3 e to the power minus 0.6 t. So this is du dt. And again, I can't emphasize this enough. For the exam, for the quizzes, you have to show your, for the exams, you have to show your work, and you have to write down what is u and du. So du is the same thing times dt. Now, when we check the numerator, everything is in order, but not negative 3. So you have two choices. Again, with the methodology that I've mentioned. You can put the 30,000 out. Okay, that's a multiply. And so, okay, I need a negative 3. Put negative 3 in, negative 1/3 out. Or, so, okay, negative 3. 30,000 is a product of negative 3 and what number? Negative 10,000. Keep the negative 3 inside, negative 10,000 outside. That's one way to do it. In other words, let me erase my word. Clearly, we have negative 10,000, the integral of, the top is du, the bottom is u squared, and what are the limits? We're going to discuss them in a moment. We're going to find the new limits. But before we find the new limits, let's remind everybody how we integrate this. We've done this already. So you're looking at u to the power of minus 2 du. So 1 over negative 2 plus 1 u to the power of negative 2 plus 1, which is simply negative u to the power of negative 1. So let's put it in this form. So before we go to the next step, negative 10,000 and negative becomes positive 10,000. U to the power minus 1 goes down. So this is 10,000 over u. What are the new limits. If I plug in 0 here, I get 1 plus 5 e to the power of 0, and I get 6. So that means the lower limit is 6. If I put 20 here, I get 1 plus 5 e to the power of minus 0.6. Let's just write it. Times 20, which is negative 12. So 1 plus 5 e to the power of negative 12 is the new upper limit. And 5 e to the power of negative 12 is the same as 5 over e to the power of 12. If you put it even into a calculator, it's almost 0. So we have 10,000 times 1 over u. We go from 6 to almost 1. This is, I put that with many decimals to show you it's almost 1.000, 4 zeros and then 31. It's practically 1. So it's 10,000 times 1 over 1 minus 1 over 6, 1 over 1, 1 minus 1, 6. This is 5, 6 times 10,000. We get this number. And since we wanted the whole number, 3 next to it is 3, 3 remains. And the initial value was 40,000. We must add it. And in the year 2040, we get 40,000 plus 8333 or 48,333 kilograms. Okay. All right. I want to go with the second method. That means, let me erase my work first. That means I want to integrate without the limits because I want to find capital G of t. So if you look at this one and come on down here, the answer is 10,000 over u and a constant. Okay, 10,000 over u. So from here to here, let me just do that too. This one, we are here. So the answer is 10,000 over u plus a constant. In other words, capital G of t is 10,000 over u, 1 plus 5 e to the power minus 0.60 and a constant, with the initial value G of 0 being 40,000. So we are going to replace the t with 0 and G of t with 40,000. So we get G of 0 is 10,000 over 1 plus 5 plus is equal to 40,000. We put it into a calculator and we find the constant 38,333. And this is the function. Again, reminding you, this was an initial value problem. This, what color do I want? So this was a general solution using the initial value. We got one of those known as particular solution, okay? And now plug in 20 and you get exactly the same answer. The thing I want to add is this, everybody. Again, as I mentioned before in other examples, the advantage of this is if they ask you what is the biomass in, let's say, 2045, this process you have to repeat the integration. But if you have this one, just replace the t with 25. So 2045, replace it with 25. So it makes it that much easier. Okay. When you evaluate the following integrals, notice they are rational functions, and the very first step in any fractional format, even if it's not a rational function, is to put them in its lowest term. To put this in lowest term, it's already in lowest term, so u would be the denominator. As you know, the derivative is 2x, du becomes 2x dx. So let's rewrite it. So it becomes clear to everybody that the integral of du over u follows a natural log, and we're going to replace the u with 1 plus x squared. And because 1 plus x squared is positive, in fact, it's always greater than or equal to 1, you can lose the absolute value and use parentheses and you're done. Now, what happens in part B, we have exactly the same u and du. So we rewrite it. And this uses the power rule. I hope you remember we've done this a bunch of times. 1 over negative 2 plus 1 u to the power of negative 2 plus 1, which makes it negative 1 over u. Again, we've done this a number of times. So negative 1 over u, which is 1 plus x squared, and a constant, is the final answer, everybody. This one, the integral of dx over x plus 3, again, has to be done with the substitution, where the choice of u is the denominator, namely x plus 3. As you know, the derivative is 1, which makes du equals dx. This is the integral of du over u, just like that. It's a natural log of an absolute value of u plus a constant. Now, of course, when you replace the u as a different u, so ln of absolute value of x plus 3 plus c, and you must keep the absolute value because x plus 3 can be positive or negative, whereas 1 plus x squared is always positive.